Gentlemen, we're here for the next question. Peter picked his favorite year, 1992, the year the Toronto Blue Jays won the World Series. Hey, Peter, who hit the home run?
Joe Carter.
Joe Carter, 1992. We've got a particle that moves along the x-axis, so its velocity is given by v of t equals 3, t minus 1, t minus 3. Isn't it nice that by 1992, we've passed from 69, we don't have to factor anymore. They've done all the factoring for us. At time 2, they give us the position of the particle is at x of 2 equals 0. That's its position. So it says find the minimum acceleration of the particle. So I got to find acceleration of that particle. I have velocity. Right. Derivate. Now I've got 3 t minus 1 t minus 3. And if I want to, I could use a triple product rule on this. I'm totally fine with that. But I think it might be easier to just, let's triple product rule it.
Could you distribute?
100% distribute. Let's do it both ways, see what happens. Let's go U, V, W. Let's see if we get the same answer. No, you just use prime 1 each time. What's U prime?
0.
Good, so we don't even need the first part. U prime, so it's going to end up being U prime VW plus U V prime W plus U V W prime. Okay, U V prime?
Is that 1?
Yep.
And t minus 3 plus 3 t minus 1. 1.
1. And that would simplify, Peter, into 3t minus 3 plus 3t minus 1. And if I need to, I can simplify it out. Let's work it on out, Peter.
Distribute?
Yeah.
So 3t minus 9 plus 3t minus 3.
So what is our acceleration?
6t minus 12.
Okay, so they gave us hold on. They gave us a velocity. The velocity goes, the time interval between 0 and 5. When is the acceleration going to be at a minimum? Well, what shape is that line right there?
Linear.
Oh, did I say what shape is that line, didn't I? What shape is acceleration? It's a line, positive or negative slope.
Positive.
Okay, so if the slope of acceleration is positive, when the acceleration is positive, slope of acceleration is positive, what's going to be the minimum value for acceleration? At the start or at the finish?
Start.
Right, because the acceleration is always going
Up.
So the acceleration will occur at the start of the interval, which is at t0. And what's a of 0?
Negative 12.
Negative 12. Let's say you weren't sure. They gave you an interval from 0 to 5. Guess what you do? You put in the values. Just put the values in. See which one gives us the start and the finish. Okay, that's 1 done. Uh-oh, find the total distance traveled. How do we find the total distance traveled?
Integrate.
We
Absolute
need
value.
to integrate the absolute value. So as a matter of fact, for this one, we're going to go to our calculator. Because we would have that for here. And we're going to go to a graph. And guess what I'm going to enter on the graph?
What?
3, parentheses, x,
I don't know, that was funny.
it was perfectly timed, x minus 1. That, when things are really funny, you usually don't know why they're funny. That's what makes them exceedingly funny.
Fair enough.
X minus 3, I'm going to hit the enter on the graph. And Peter, I can see that that graph in that time frame has some positive and negative stuff. So if I don't want to integrate velocity, I'm going to tab back up here. Watch what I'm going to do, Peter.
Integral sign?
I'm going to, right in here, no, I'm going to do the absolute value. Oh, that's not the absolute value, Peter. Come on.
Couldn't you use the calculator page?
I could, but I just want to see what it looked like first. And I'm going to go to the calculator page in a second anyway. Var, where's F1? Well, I can put this in the absolute. Yeah, hey Peter, let's just go to the calculator page. Control plus. I'm going to integrate. Menu. Calculus. Integral. Where am I integrating from, Peter?
0 to 5.
0 to 5 of what function?
Velocity.
Yep, which I stored in F1 of x dx. But if I hit enter right now, it's not going to give me the total distance traveled. It's going to give me the displacement because it's going to combine the positives and negatives. So just as Peter said before, I've got to put this in the absolute value. 1 of x. There we go. Look good, Peter?
Mm-hmm.
Peter's okay with it. And the answer to that is
28.
28. Total distance traveled, 28. So now it says find the average velocity of the particle over the interval 0 to 5. Okay. Average velocity. Here's the question. Do they want me to find an average slope or an average value?
Well, it's the values of that function.
Correct. It's the values of that function, so I'm looking for an average value. I'm looking for the average value of which function? Of v of t between 0 and 5, and then divided by,
5 minus 0.
which is 5. So we'll just grab this, we'll do 1/5. And you, 4, 3, 0 to 5, f of x, x dx. We hit enter, and Peter, there's our average value, 4. So we had a problem that involved physics again, velocity, acceleration, and no displacement here, but we had that. And they asked us about the average something. The question is, was it slope or was it value? In this case, it was about velocity, which is sometimes slope, but because velocity was the function we had, it's the values of that graph. Good job. We'll see you folks in the next video.